Alright, good day guys. How are you all doing? I guess I've heard a lot of discussions about electronic configurations of some atom that some of them doesn't take the main configurations like that. Actually they all do, but just that there are some little things that guides them through. Now we all know that this is our normal configuration, right? And there's something you have to know. You see this arrow is just like a stepper. But the main category we have to look at first, you have to look at the stepper, the row, and also you have to look at the normal horizontal categories. And if you have to look at this after 3D, you know you have 4s, right? Which means 3D is lower than 4s in an horizontal category. Remain looking at it. They call this horizontal category. So these two things are what we are going to look at, and also again the noble gas that carries them along. Now let's start from aluminium. Now also again talking about aluminium, one more thing, you have to deal with their outermost shell. Those are the four things we need to look at, the outermost shell. Now if you look at aluminium, you know aluminium is actually what is 13. That means you have 2, you have 8, and you have 3. That means the outermost shell of aluminium is what is 3, right? Now let's talk about the configuration. You have 1x square, you have 2x square, following the normal stepper. You have 2p, p takes 6, and you have 3x, so 6 7 8 9 10, and you have 3x, 3x raised to power 2 rather. And what else do we have again? You have a 3p1. Are you getting what I'm saying? You have a what? A 3p1. Now from this you could easily understand something. I do that we have the noble gas, right? Now if you are to look at this under this particular textbooks, I want you to explain something. But before that, let me talk about something. Now some people categorically, they used to ignore the rest. They only take the outermost shell, and the outermost shell we have there is 3, which is from 3s square and 3p what 3p 3s and 3p. Let me just put it that way. Are you get what I'm saying? And if you are to look at this, you can bring them out as 3x square and 3p1. Are you get what I'm saying? Now you will now enclose it inside brackets. And mainly most transition metals are from d orbitals. Are you get what I'm saying? And there are some explanations of those ones. We won't get to that now. From here, I've categorically bring it out, Abby. You can see it written as like this, but there will be a particular element at the front here. And how do they count that element? This is how they count the element. The elements are always noble gases. Now if you look at helium now, you see that helium, I get what I'm saying, is like the next for all the next elements here into in this second group here, this horizontal group here. Neon is the next second noble gas for everything here. Now if you look at now, aluminium falls under what? Under neon. So that is why you see they will write it Ne, 3x square and 3p1. So they use this configuration in most cases for it. So all you just have to understand is look for the what? Look for the outermost shell, and everything else might literally be much more easier for you to debunk on. Now let's look at something much more crazy. Let's say we have manganese. Now manganese is 25. That is 2. You have 8. You have 8, and you have 7, right? 18, 19, 20. Yeah, you have 7. Now our outermost shell is what? Is 7. This is what we have issue with. Now write it normally. Write it normally. Let's say you have 1x square, 2x square, right? You have your 2p6. You have your 3x square, right? And you have your 3 p. You have your 3p6, and you have your 4x square. Then you have your 3d. Now let's count from here. You have 10, 12, 18, right? 20. So though the d orbital, s orbital takes maximum of 2, p takes 6, d takes 10, and f takes 14. So which tells us that d here is yet to be completed. It has 5, right? And I told you that it is only our outermost shell we deal with. That means between these two values. Now there's something you have to know. Are you get what I'm saying? When it comes to the d orbital, that's from the transition metal, at times they usually switch it. That's you having 3D comes um to the front, then 4x square. There is no difference. It's still the same thing. Are you get what I'm saying? So at times they might switch it like this in some question. Yes. Now, just like the way we had to categorize it, you have brackets, right? Because that is the two we deal with. Now you now have to look. Now manganese falls after what? Now then you look. We say neon owns all these idiots here. Now argon owns all these idiots here, and manganese is part of the idiots, which says that what you'll be having Ar, then your what your electronic configuration, which is 3d raised to power 5, 4 raised to power 2. So either you say 4 raised to power 2, 3d raised to power 5. It is still the same thing. You're on the right track. Now people do ask that what if you have something like Mn2 positive? Now we all know that when a particular element becomes positive, that means that it has loses that particular electron, right? Now it is still easier again. Are you get what I'm saying? Where you have to still deal with is still between the two. Are you get what I'm saying? Still between the two. Now since we know that manganese loses 2 electrons here, right? You will now come here now, you now look. If I'm to remove 2 electrons here, this is gone. This is gone already. Then it is not enough. This is gone already. That means that if I'm to have Mn 2 positive, it will be Ar into bracket or 3d raised to power what? 5. Are you get what I'm saying now? So to make it much more easier, that will give me 3d raised to power what? 5. So let's say we have 3 positive, and you know that will be what? You remove one more, that will be 3d Ar, then what? 3d raised to power what? 4. So this is how all these things actually work. Now let's assume you have okay, what if we have the noble gases themselves? Let's assume you have the like neon. Let's say you have neon, and you know neon is 10, right? Which means that it does not have a problem with the outermost shell. Yes, but we need to give it problem as of. So you know you have 10, you have 2, and you have actually 8, right? For neon, which is 10. So we know that will be 1x square, 2x square, and 2p6, right? And we know what our problem is between what? These two categorically. These two. So as you know, now look at neon. Since neon is a noble gases, then which one will now represent the noble gas? Yes, it is a noble gas versus a noble gas. So you now look at now. You will now look it again. Neon, helium is the what? Is the king to everything here. And since neon has fallen under it, helium will be the king to neon. That is, you have He, then what? Your 2x square and 2p what? 2p6. So that is how they govern the rules for this. So I hope we all learned something under this. In our next class, I'll talk about the hybridization on some particular atom.